In this video, we're going to be looking at converting back and forth from degrees to radians. Okay, so I want to remind you that when you have a circle, okay, and if you have an angle whose initial side, let me get the circle on there first, okay, and if you have an angle whose initial side is on the positive x-axis, and you rotate all the way over to the negative x-axis, then you went from 0 degrees, you went all the way over to 180 degrees, okay? All right, and that's degrees. Now, if you thought about that in terms of radians, one of the things the video demo was trying to show you is that the length of the radius, whatever it is, always winds up being 1, 2, 3. This amount of rotation turns out to be 1, 2, 3 radiuses along the intercepted arc, plus this little bit right here. So it's 1, 2, 3 radiuses plus this little bitty amount right here, which turns out to be around 0.14. In reality, it's 3.14, which would be the same as pi. Okay, so the length of that intercepted arc turns out to be pi radians. Well, that's going to be the conversion fact that we're going to wind up using, is that 180 degrees is the same as pi radians. And if you just said pi, that's okay, but it helps to really understand that that's radians. All right, so then we're going to be using unit fractions. Those are fractions where they're really equal to 1. See, pi radians and 180 degrees are really the same thing. So it's really equal to 1. And it might be that we want the radians on top. It might be that we want the degrees on top. So we might write it that way, or we might have it flipped over. Let me move this over a little bit. So we might use the unit fraction so that we have, I'm going to write a little smaller, pi radians over 180 degrees, or we might want to have the 180 on top and the radians on the bottom. Okay. All right, so we're going to look at how to do this. So the first few problems deal with starting with degrees and converting to radians. Okay, so one way to think about this is to use these unit fractions. Why I like that is it helps you know whether you should multiply or divide by the 180, because that's usually the question that I get. So what I want you to do is to think about 240 right now as being 240 over 1. And it has a degree symbol. And what I'm doing is something called dimensional analysis. We can work with the units like we work with numbers when we're simplifying fractions. Since I don't want degrees, I want degrees on the bottom, so they'll cancel out. So that tells me the 180 should be down here, that I need to divide by the 180. Okay, so I'm going to use the unit fraction that has radians on top. Then you see how the degrees cancel, and we're left with this 240 over 180 that needs to be simplified. And so you just work on reducing that fraction. So one of the things you notice, okay, so far we're to here. Okay. So one of the things you notice is that you can divide by 10. So you might go ahead and do that, get you down to here. And then I notice I can divide by 6. And so that gets me to 4 pi over 3 radians. Okay. All right, so let's try another one. So if we work on 60 degrees, degrees is on top. So that means we're going to be putting the 180 on the bottom. Okay, so now the degrees will cancel out, leaving me with radians like I need. And then I can tell that 60 goes into 180 3 times. So 60 degrees is the same as pi over 3 radians. All right, now let's take negative 135 and do the same thing. Again, I'm going to want the degrees on the bottom. Okay, so I'm going to do multiply by pi radians over 180 degrees. The degrees, the units cancel out and leave me the radians like I need. And so I'm sitting here with this equal to negative 135 pi over 180. And that's in radians, but I got to reduce that. And this one you might not see right off the bat what you can divide by. So I noticed they end in a 0 and a 5, so I might divide by 5 first. If I divide by 5, it's going to go in there 27 times on top. On the bottom, when I divide by 5, it's going to go in there 36 times. Oh, and then I can see that 9 goes into both. Then 9 goes into 27 3 times, and down here 4 times. So I wind up having a negative 3/4 pi on that one. All right, so you probably have the idea on that. So I'm just going to do the last one kind of quickly. So we're going to multiply by pi over 180 degrees. Okay. And then on this one, I can knock out the divide by 10. Also knock out the degrees. And then I can see that 3 would go into both of these. 3 goes into 15 5 times, goes into 18 6 times. So your answer on that one should be 5 pi over 6, and that would now be in radians. Okay. All right, now I'm going to show you 2 ways to think about converting an angle that is starting in radians and you're converting it to degrees. If it has a pi in it, there's a couple ways you can do this. Okay, first off, we could think of it, this is probably to me the best way for you to think about it. We could think about how this is starting out in radians. Okay, so radians is like up there on top. So what we want to multiply by is a unit fraction that has radians on the bottom, which means we need 180 up here on top and pi on the bottom. So we're using that dimensional analysis idea, the unit analysis. So you can knock out radians, and that means your unit is going to be degrees like you want it to be. That kind of means you set it up right. And then notice that the pi will cancel this pi right here. Now we can continue our simplifying because 6 goes into 6 once, goes into 180 30 times. And so then we just collect what we've got left. We have a 7 times a 30, which is 210 degrees. Okay, so that's a really good way to do all of problems 4 through 7. But if you do have one, let me do it in a different color. Another approach that works well if you have an angle that has a pi in it is to remember that pi is 180. So if this is in radians, okay, you can replace pi radians with 180 degrees. So you can say 7 over 6 times 180 degrees, and then you can reduce and get your 210 degrees, okay? So that works good if there's a pi to start with an angle in radians, okay? All right, so let's look at number 4. So we could use that idea on number 4. So these are in radians, okay? So this one's starting out pi over 4 radians. So what we could do is just replace the pi radians with 180 degrees. Make sure you divide by the 4, and it goes in there 45 times. So it'd be 45 degrees. Or we could do the pi over 4 radians times the 180 degrees over pi radians. And then you see the unit and the pi cancels, and 4 goes into 180 45 times. So both approaches work. All right, number 5 had a pi in it, so we could use that kind of shortcut because pi in radians can be replaced. So we have negative 4 over 3 times 180 degrees. 3 goes into 180 60 times. And so we wind up having negative 240 degrees when we are finished. Okay, and it again would work if you used the unit fraction idea. If you multiplied by 180 degrees over pi radians, canceled out radians, divided there, canceled out the pi, you'd get that same end result. Okay. Now, on 6 and 7, you can't use that shortcut of replacing pi with 180 because you don't have a pi. These are in radians to start with. So if you're working on these, you really got to use that conversion where you multiply by 180 over pi, which is a unit fraction. So it doesn't change the size of the original problem, it just changes the name of it. So you see on that, radians would go away, and we'd wind up with 180 over pi degrees, which is not, this is really, really tricky, which is not 1, because that pi on the bottom is just the real number pi, just the 3.14. It's not radians. Okay, so that can be really tricky. So if you take 180 and you divide by pi, and you have some calculators have a pi button. If not, you can use 3.14 in place of it. You're going to wind up getting that is about 57.3 degrees. Okay, so an angle that's 1 radian is around 60 degrees, a little less than 60 degrees. All right, so let's do this one. Negative 15 is in radians. We're trying to convert to degrees. So we're going to multiply by 180 on top and pi radians on the bottom, knocking out the radians. And then I'm just going to wind up using my calculator and multiplying negative 15 times 180 and then dividing that by about 3.14. And I'm going to get around negative 859.4 degrees. Okay. All right, so that's a quick video on just converting back and forth between radians and degrees.